Every time someone logs in, updates a profile, or passes KYC, you're quietly making regulatory bets. In the age of AI, those bets can mean fines, scandals, or a powerful trust advantage. In this module, we'll unpack the rules that actually shape digital identity design. You can think of a modern identity system as resting on 6 pillars of data protection. Lawfulness and purpose mean you only collect identity data for clearly defined workflows, not just in case. Data minimization means defaulting to the least data possible, like age range instead of full birth date. Accuracy relies on giving users simple ways to review and correct their information. Storage limitation focuses on auto-deleting data once it's no longer needed. Accountability and integrity bring in audit logs, encryption, and least privilege access to make those promises enforceable. Regulation may look fragmented by region, but it's converging around a shared direction. Europe pushes the bar on transparency, cross-border trust, and biometric safeguards. North America leans into consumer control, opt-outs, detailed consent, and tight rules for financial and health data. Across Asia-Pacific, new laws emphasize governing cross-border data flows and sensitive attributes. For digital identity design, the signal is consistent. Build for stronger user rights, radical transparency, and auditable accountability, even if you operate in only one region today. Historically, many organizations treated privacy like a patch. Design the product, ship it, then scramble to fix whatever regulators or users complain about. In identity systems, that's slow, expensive, and risky. The modern approach is privacy by design. Privacy and security are woven into concept, product design, and engineering from day one. And with privacy by default, the most protective setting is the starting point, not something users must hunt for in a menu. Consider a bar or fintech app that only needs to know whether you're over 18. The legacy mindset says, copy your entire ID into their database. Name, exact birth date, address, license number. That creates a pile of toxic data, perfect for breaches and misuse. A modern compliant mindset uses a cryptographic filter. With techniques like zero-knowledge proofs, the system only learns the answer to the question it cares about. Is this user over 18? Nothing more, and nothing reusable for tracking. Consent patterns are where identity UX often drifts into manipulation. Bundled consent forces users to accept everything just to continue. It hides real choices, damages trust, and increasingly clashes with regulation. A better pattern is granular contextual consent. Ask only for what you need at the moment it's needed in clear language. Separate core identity verification from optional marketing or analytics, and make revoking consent as easy as giving it. The goal is to design for agency, not just acceptance. Picture your identity system as a high-security vault. First, protect the vault itself. Store credentials with strong hashing, encrypt data in transit, and manage sessions tightly so stolen tokens are useless. Next, control internal movement with least privilege and attribute-based access control, so people only touch data that matches their role or context. Surround all of this with strong multi-factor authentication. And finally, log every meaningful action in tamper-resistant audit trails, so you can investigate incidents and prove what actually happened. Using biometrics means handling some of the most sensitive data possible, so the bar is higher on every dimension. Start by treating biometrics as special category data. Default to minimization, strong consent, and the narrowest legal basis you can. Then lock in strict purpose limitation. A template collected for authentication must never quietly become a profiling or surveillance tool, and assume your models drift over time. Continuously test them for accuracy and demographic bias, and tie those results to real governance and escalation paths. Whenever someone tries to log in or open an account, an AI risk engine is increasingly the first decision maker. It scores the attempt, then either lets the process flow smoothly, asks for extra checks, or blocks it. The critical governance choice is what happens at high risk. A non-compliant design simply rejects people with no explanation. A compliant, trust-building design generates a clear, explainable reason and routes the case to a human reviewer. Many regulations now require that kind of human review and meaningful explanation when automated profiling affects access to services. AI identity systems fit well into a risk pyramid. At the bottom, minimal risk users like spam filters still need security and privacy. but mostly follow standard data practices. As you move up to high-risk uses, such as remote biometrics or automated identity verification, the bar rises sharply. You now need formal impact assessments, tight control of training data quality, and ongoing monitoring for performance and bias. At the very top, some use cases, like social scoring, may simply be considered unacceptable. All of this adds up to a mindset shift. Legacy identity architecture assumes collect everything now, maybe use it later. Compliant architecture starts with minimization, only what's necessary, or even just a cryptographic yes-no proof. Consent moves from one giant terms of service to small, timely choices tied to a specific action. Identifiers evolve from one global ID that enables tracking to opaque, context-bound tokens. And AI goes from opaque scoring to explainable models with clear human review, especially for high-impact decisions. You can also picture digital identity architecture as a stack where compliance is baked in, not bolted on. At the bottom, your data store enforces encryption, pseudonymization, and immutable logs by default. Above that, interoperability standards like OIDC and verifiable credentials keep you from building isolated silos. Then the logic and AI layer applies transparent risk scoring and policy-based decisions, so you can explain every outcome. Finally, the UI layer turns those rules into granular consent and just-in-time notices. Change any layer and the trust properties of the whole system change. Everything you design around digital identity should do 4 things. First, make data flows explicit, so you actually know what you're securing. Second, assume privacy by default, so consent and minimization are baked in, not patched on. Third, govern AI and biometrics like critical infrastructure. And finally, treat regulation as your playbook for long-term trust and adoption.